All right, good day, Nursing Chem students. We're going to try to finish chapter 10, but before we do that, we were on a farther slide than this, slide 25. Before we do that, I want to go over a little bit of business. So I'm just going to draw a line here, and I'm going to say, so business. Remember that the chapter 10B homework is due, let me see, the 27th, okay? Remember, and this recording is for Tuesday the 26th for lecture. Remember that we have a quiz on 10B material Thursday, okay? So that's Thursday. And then Thursday the 24th, excuse me, not 24th, the 4th is exam 3. Okay, and if I have a chance in my email, I'll list what I want you to know for this week's quiz. But for now, I want to get through the lecture material because this software allows 15 minutes of material. Okay, so that's just the business items. Now remember, we had these three, so 1, 2, 3 reactions that were acid with, and it was acid with a base. And so this is acid plus base, and we called it a neutralization. And what I want you to know is that is gonna produce, this is sort of the summary, water plus the salt of that metal, and the salt is always going to be aqueous. Okay? Acid with a metal is going to produce always hydrogen gas and the salt. Also going to be aqueous. You need to have your phases in here. And then acid with some kind of carbonate. So this wouldn't just be plain carbonate like the polyatomic ion you see here. There would be a metal or some cation bound to that carbonate, but in general we just say the carbonate. So it would be in an ionic bond in a salt, but that's going to produce three things. CO2 gas, water, that's going to be liquid, and again we'll see the salt in the aqueous phase. Okay, so that is actually the summary of the whole rest of the chapter. But the last thing you need to do once you have your products is to balance the equation. So let's go through them. We looked at neutralization last time, but we'll do the first one again, acid with a base. So remember, the waters from the H from the acid, the OH from the base usually makes up the water component, and then we had to put our ions, the metal here, sodium, and the non-metal chloride anion, and make our salt. Okay? This was just an example of a variety of antacids, so these are going to be acid plus an antacid. Some of them, like for example this milk of magnesia, was in lab, that you should have gotten a basic pH. That would produce a neutralization that would just be salt and water. So here's an example of a neutralization. Stomach acid is HCl, the magnesium hydroxide. Now I will say you need to make a note. I'm going to show all the slide. There we go. You need to make a note of what is an acid versus what is a base. You've got to be thinking, what are the 6 strong acids? Oh, if I see an OH, you're thinking most likely the hydroxide is going to be the base. But if you've memorized your 6 strong acids and your 6 strong bases, that's always a good place to start. Now, these steps are the steps that come from your textbook. You can balance in any order. You can write the products. You should have enough practice with balancing that this should be pretty straightforward, okay? So you've got the water that's produced, the magnesium chloride, that you should be very familiar with the fact that you now have Mg with the Cl sub 2 here, okay? And then you balance it. You need 2 waters, you need 2 of the HCl molecules in order to have the whole thing balanced, okay? So that's one example. For the sake of time, we're going to move on to the second one. So this is like acid with a metal. This is like number 2. So acid with a metal produces hydrogen gas and the salt. So those were the 2 products I wrote initially. So here are 2 completed examples, okay? So you need to be able to look at this whole thing and recognize what is going on here, what kind of chemistry, okay? There's an acid. I should recognize an acid. The only thing present here is potassium, which is a metal, okay? So Metal plus acid. All right, how do I make my products? Well, it's going to be a memorized H2 gas. Remember, hydrogen can be one of those diatoms. Okay, hydrogen as well as like I2 is a good diatom. Some of the stuff in the group 7A elements. And then you take this metal and the non-metal and form an ionic substance and balance it. You do the same thing with the zinc. Zinc is a metal found on the periodic table near in the transition metals. Same acid as the other equation. Hopefully you should recognize hydrochloric acid by now. And the zinc chloride has the little sub 2 because zinc has a +2 charge. Okay. Acid with a metal, going back one. Acid with a metal here is showing same acid, but now you need to recognize the metal. So all of them have the hydrogen gas. It's the salt that students often have an issue with because you just stick, for example, MgCl. That's wrong. Or you might try to put a 2 in front of it and do MgCl and then way over here put like a 2Mg. That's also wrong. Okay? That's wrong. So make sure you use your material that you learned way back in chapter 6. All right. Acid with carbonate is the hardest. It's the hardest because you're taking this carbonate and you're kind of actually chopping them up, whereas before I kept saying keep the polyatomic ions together. So once you've recognized the polyatomic ion, you're like, okay, I recognize the acid, I recognize that I've got something with a carbonate in there. Do the two big products, the carbon dioxide gas and the water by themselves, and then you can say, okay, I've got to make a salt. Well, over on the left side, the only possible cation is this guy, because the water stole the H, so the H is used up. Okay? So the only possible salt is the calcium, or the cation, excuse me. And we've already used this, gets turned into the carbon dioxide, and some of the oxygen goes into the water, okay? So that can't be used. The rest of the options are only the non-metal there with the Cl. So Ca and Cl, 2 plus negative, make our CaCl2. I can't write the CaCl2. There we go. Okay, that's the hardest one. Here's another example. This is a little bit harder because we actually have two cations, but you still recognize the carbonate. Same carbon dioxide, same water. So you kind of like, he can't be part of the salt. The H can't be part of the salt. This H can't be part of the salt. What does that leave? Oh, sodium chloride is our salt. Okay. On the exam, you're going to basically be given the two reactants, and you have to write the whole products and balance the whole thing. For the quiz, you just need to memorize. It's a multiple choice question. You just need to memorize. I'm going to give you an acid reacts with, and I'm going to give you one of the three choices, and then the multiple choice answers are basically these words that are kind of in blue here. Carbon dioxide, salt, and water, that kind of thing. Or memorizing neutralization. I'll say an acid with a base, and the correct answer would be, oh, it forms a salt and water. Okay? That's for the quiz on Thursday. Okay, so here's another acid with a carbonate reaction. Okay, another option. HBr was one of the 6 strong acids you had to memorize. Once again, recognize the carbonate. Okay, so you should be able to identify, all right, got my carbon dioxide and water. Identify those automatically. The salt might take you a minute, but you see a cation here with a beautiful anion there. Make sure your charges match the charges they form when they're ions on the periodic table, and you can write your salt. This, in order to balance at the end, I want to emphasize all of these have been balanced with the various coefficients. Okay, so pay attention to that. That doesn't go away just because we're learning how acids react. Okay, so I'm leaving this blank because I want to mention, you don't have any more slides on chapter 10. I want to mention an example here. So let's see if we can do another example. By the way, there are examples at the end of section 10.6, page 348. But I'm just gonna pick, let's do 10.43 letter D, okay? So 10.43 letter D. All right, so basically the question is complete and balance the equation that's listed below, the equation for each of the following reactions. So you're just given, I'm sorry my handwriting's bad here, plus Mg OH2 solid. Okay? You don't know what this is? Okay, so I don't see carbonate anywhere, so it's not an acid with a carbonate. I don't see just a plain solid metal, so it's not an acid with a solid, so that would leave us with the neutralization. So first thing is neutralization. So then you memorize, oh, the products, just for the sake of space, I'm going to try to write this smaller. The products are going to be, water we got. That's done. Then we need to have the salt, okay? Well, there's my metal. So make a little Mg2 plus. We're already using up these here for the water, and there's my ion, SO4 negative 2. Oh, sorry. SO4 negative 2. MgSO4. The question is this balanced or not? And for the sake of time, we're not going to go through all of the balancing, but in order to fully balance it, you're going to need a 2 in front of the water. Oh, I forgot the salt is aqueous. Okay? I'm going to run out of time, so let me make a note for your quiz. So for the quiz, that way I don't have to include it in the email. You're going to have information on the pH scale and the litmus paper, which you learned about in lab, and we've gone over. I will say table 10.6 is important for the quiz. 10.6 is important. You will have a question on the reactions that we just looked at, the different acids with something. Okay, you'll have a question on those. Let me see what else is on here. And you're going to need to know the definition, the Bronsted-Lowry definition. You need to know that, that says definition. You need to know that because you're going to be given a reaction, a complete reaction, and you're going to have to identify either the acid or the base. Just like, remember how I said you're going to eventually have to identify acid, base, conjugate base? You're going to need to identify all of those. Okay? So that's on the quiz, general acid-base information type stuff. That's pH scale, litmus paper. You know, high pH is basic, low pH is acidic, that kind of thing. But this we went over last time, so go back if you're confused by that. We went over that in the beginning of chapter 10. If you're confused by that, go back through it in the book and you can see, oh, in this case, this substance is losing an H, therefore he must be donating. Donating his H, and that would make him the base. Oh, this substance from the reactant side to the product side, he's gaining. You know, if water goes from here, and now after he's H3O plus, he has gained an H. Gaining an H is therefore, this guy is acting as a base. That's what you need to recognize, okay? Please email me if you have any questions. Thank you.